Helical piles, most commonly known as screw pile and helical pier, have been around since the 1800s, and they are devices that are screwed into the ground to be used as a support foundation. The steel piles come in all sizes from 2-inch up to an 8-inch in diameter. Over the years, helical piles have grown in the construction industry and are used to support small and large buildings, homes, walls, pipelines, boardwalks, bridge abutments, telephone poles, and now with the growth in the green movement and increase in renewable energy projects, they also can be used to support ground-mounted solar arrays. With solar arrays, the array is very light for engineering consideration. The critical angle and demanding criteria for a solar application is the wind, height above ground, and module orientation angle. Think of the array as a wing. The wind will tend to lift the structure. Thus, determining the wind speed, tilt angle, and soil quality at the site are necessary to design the proper foundation system. These criteria will determine the shaft diameter of the pile and the helical configuration of the pile. Here is a list of the information you will need in order to determine the amount of material needed. Once the size of the pile has been determined, you will only need helical piles, a drive head, your 2-man crew, and the skid steer loader to get started. The pile should be installed by rotary-type hydraulic motors with forward and reverse capabilities, and these units shall be capable of positioning the hydraulic head at the proper installation angle. Once the location site is surveyed and staked off, the crew will offload and set the piles at the marked locations. The operator of the skid steer loader begins by sliding the bobcat into the utility plate, locking it into place, and connecting the hoses. One crew member will set the helical pile in the correct vertical position as the operator of the skid steer loader inserts the adapter of the drive head into the top of the pile. They line up the punched holes, stick in the steel fingers through the holes to attach the pile to the drive head. The operator will then start the helical pile installation, which on average takes a minute drilling time per pile. You will note that there is no devegetation of the soil. Therefore, the helical pile in the process will not cause erosion, unlike other foundation alternatives. When drilling, the operator will monitor the hydraulic gauge until proper installation torque or prescribed pile depth is reached. At that time, a bracket may be placed on the pile to connect to the racking system of the solar array. Soil quality generally increases with depth. As soil quality increases, torque required to drive the pile deeper increases as well. The helical piles have become a more feasible solution compared to using concrete to stabilize the solar array. The piles have several benefits when compared to using concrete, including time and cost savings. When using concrete, the site grounds have to be prepped by excavating, removing the excavated soil, marking the foundation spots, surveying, pouring the concrete, setting the posts, and bracing them for the curing process. It takes a considerable amount of time, and we all know time costs money. With the helical piles, you merely mark the spots by surveying, install the piles, and they are ready immediately for racking. Helical piles are a sustainable solution because they can be unscrewed from the ground and reused once the land lease or PPA has ended. Using helical piles as a foundation support for the ground-mounted solar array is a cost-effective, time-efficient, and environmentally sound solution. This technology has stood the test of time for a reason.